Hello everyone, welcome back to my channel. I am Lavanya Vaishnavi. Today I am going to take up the topic Semiconductor Diodes and its application. So today is 11th session. I am going to discuss about some numericals on diode.
Now we will take up few problems on silicon and germanium diode. So these are very simple problems that are based on biasing conditions of silicon diode. So they are very easy and it may hardly take 2 or 3 minutes to solve for you. So the first one is a silicon diode has IS, that is reverse saturation current of 10 nanoamps operating at 25 degrees centigrade. Calculate ID. What is ID? ID is the diode current for a forward bias of 0.6 volts. That is, you are applying 0.6 volt for silicon diode and you need to find what is the current ID if the saturation current is 10 nanoamps. So let us start the calculation. Before starting the calculation, I'll just write down what is the equation for current. We know that ID is equal to IS into e power k into Vd divided by Tk minus 1. Okay, this is the expression. In this, I know the value of Is. So, I need to find out what is K. Vd is already given. So, it is zero 0.6 volts. And I need to know what is Tk. So, Vd is given, which is 0.6 volts. K, we don't know what is K. So, the value of K is 11600 divided by eta, which is 11600 divided by 2, which is 5800. Okay. Tk is the temperature in Kelvin. So, Tk value is equal to 25 degrees. So, in what units they have given? They are given in degree centigrade. I need to convert that to Kelvin. 25 plus 273, right? 273. It is 298 Kelvin. It is 298 Kelvin. Now I can substitute all these values in diode current expression. ID equal to IS is already given, which is 10 nanoamps. So see here, Is is already given, which is 10 nanoamps into e power 5800 into Vd. Vd is 0.6 divided by Tk values 298 minus 1 minus 1. So which is 10 nanoamps into e power. So this value is 11.68 minus 1. So ID is equal to 1.18 milliamps. So if you use the calculator and calculate it, you will be getting the value of 1.18 milliamps. Okay. Coming to the second problem, for the circuit shown below, find the current I using approximate model of the diode. So using the approximate model, I need to find the current value I here. Now, so this is a normal diode, that is a practical diode. So the approximate model comes with a threshold voltage and an ideal diode. Threshold voltage and ideal diode. The threshold voltage for silicon diode is 0.7. Threshold voltage for silicon diode is 0.7. That I have to replace here. Now, first thing what I have to make note is, so where is the anode of diode connected to? And where is the cathode of diode connected to? Okay. So, anode of diode is connected to negative. Cathode of diode is connected to positive. It means diode is in reverse bias. Diode is in reverse bias. In reverse bias, diode acts as an open circuit. Okay, this is the analysis I have to make. Now, the complete circuit I can write it as, so the silicon diode is now open with the DC source. You have a resistor and the current is flowing here. Okay, whatever may be the value of the source, sorry, it is minus and here it is plus, okay, whatever may be the value of the source, because you have an open circuit here, the current flowing is equal to 0. Current flowing is equal to 0 because the diode is reverse biased. So no current flows here and the current will be equal to 0. Now, look at the second circuit. In this circuit, you have a silicon diode connected to a source. Now, this cathode is connected to negative, anode is connected to positive. That is, diode is forward biased. So, it is in a conducting mode. Now, if I rewrite the circuit, so I need to find the current flowing through the silicon diode. I don't want, or I'm least bothered about this 10 ohm resistor, or I can tell that the current I is independent of 10 ohm resistor now, okay, because I need to find the current here. I know the voltage drop across these 2 points, so whatever may be the resistance here, that doesn't bother us. So now if I write this circuit, it will be like this. See, where is this current flowing from? It is flowing from this point to this point. Now I will rewrite the circuit. Negative, so negative, positive, this is anode, so positive, and you have a 20 ohm here. This is the direction of current, and you have the source here, okay, this is 20 volts, this is 20 volts. Again, here I have made a mistake, please change it. So this is negative and this is positive, okay, it is 0.7 volts. Now applying the Kirchhoff's voltage law, so I'll go with the direction of current. Current is moving upwards, right? I'll take the same path. So like this, I'll take the law. Now, if I move like this, I'll get this as plus 0.7. And if I encounter this, I got it minus, right? Minus, plus, minus, plus. So minus 20. And it is in this direction only I'm taking the arrow. So the red arrow and the black arrow are in the same direction. So it is plus I into 20 equal to 0. So I is equal to 20. If I move this to the right hand side, 20 minus 0.7 divided by 20. The value of current is equal to, in this third part of the circuit, you have two diodes, silicon 1, silicon 2 diodes. Now, silicon 1 diode, the anode terminal is connected to negative, cathode is connected to positive. Here, cathode is connected to negative, anode is connected to positive. That means silicon diode 1 is reverse bias, silicon diode 2 is forward bias. That is, silicon 1 is open and Si2 is closed. It means that the complete path is an open circuit. So the circuit, I can write it like this. You have voltage source, which is 10 volts, and you have current I flowing through the 10 ohm resistor. Fine. So what happened to the path here? It is an open circuit. So I need not to mention it. So now let me apply the Kirchhoff's voltage law. I'll take in the direction of current like this, okay. So black and red arrows are matching now, right? Yes. Now it is plus I into 10 plus I into 10 plus 10 volts is equal to 0. Now I is equal to, let me move to the other hand, it is minus 10 divided by 10. I is equal to minus 1 amp. I is equal to minus 1 amp. So this is the amount of current flowing in the circuit. Now the third problem is for the diode circuit given below, find the ID and V naught using approximate model. You need to find the current ID and V naught. Where is current ID? So here it is. V naught is given here. Look at the diode. The negative terminal of diode is given to minus 5 volts and the plus is given to plus volts. So I'll rewrite the circuit here. The negative terminal is given to minus 5. It means minus plus minus plus, right? So this is how your silicon diode will be. Now it is 5 volts minus and plus, and that is a silicon diode. I need to find V naught. Here you have 2.2K current ID and it is grounded here. So here you can ground it. So I have taken joined it and grounded here. Now I know the circuit now. Now applying Kirchhoff's voltage law, I'll take the direction of current in the same direction of this ID. So here the arrowhead is meeting plus, right? So it is plus 5 volts, and if I come here, it will be negative positive 0.7 volts. So minus 0.7 volts plus ID into 2.2K. Why it is plus? Because this direction, see, it is flowing through this direction, right? See, right? So this direction and this direction, the red line and the black line, both the arrowheads are in the same direction, so it is plus. If they are in the reverse direction, I should have taken minus. So plus ID into 2.2K is equal to 0. I need ID. Push this to the right hand side. It becomes 5 minus 5 plus 0.7 divided by 2.2K. So ID value will be equal to 1.95 milliamps. Okay. The next part is V naught. To find V naught, I just need this part of the circuit. I'll just extend this. Okay. Here it is V naught. In the sense, this is plus V naught and this is minus, and hence it is grounded. Now I'll take the same direction of current here again. Okay. Like this. Now I'm getting minus first, right? So I'll take minus V naught. So this is first part and this is a second one to find V naught. So minus V naught plus ID into 2.2K equal to 0. So we know ID, we need to find V naught. Let me push this to the other hand side. So V naught is equal to ID into 2.2K, which is, so here you have minus 1.95 milli into 2.2K. V naught value will be equal to 4.3 volts. So the value of V naught is minus 4.3 volts. It is minus 4.3 volts because you have a negative current here. It means that the current is flowing in the opposite direction. The current is flowing towards the resistor, not towards the ground. So this is what minus sign indicates here. Okay, so even the voltage is minus 4.3. That is, you have to connect minus here and plus here to get plus 4.3. That is what the significance of signs are. Okay. So in the next circuit, you have a plus 8 volt and a 1.2K resistor with 4.7K, and this is the current direction. You have silicon diode and V naught. Okay, so if I rewrite the circuit, this becomes plus 8 is there, so positive, negative, that is given to 1.2K and it is given to 4.7K, and here you have a silicon diode, right, and you have V naught here. The current is ID. Okay, so this is 8 plus 8 volts, right? Now I need to find the value of current ID. To find the value of ID, I will just apply the KCL again. Sorry, KVL again. So I'll take the same direction here, like this. Okay. So because I have no other components here, the complete current here will also be ID. So it is minus 8 volt plus ID into 1.2 kilo plus. So here also ID into 4.7 kilo plus. What is the value of silicon diode? It is plus 0.7 equal to 0. I need to find ID. ID, I'll take ID common here. It becomes 1.2K plus 4.7K. I'll push this to the right hand side, which is equal to 8. This to the right hand side minus 0.7. Therefore, ID is equal to 8 minus 0.7 divided by 5.9K. The value of ID will be equal to 1.237 milliamps. 1.237 milliamps. So the next is I need to find the value of V0. To find the value of V0, I can write. So here only I can calculate it. So let me take in the same direction of ID. Okay. So it becomes, see, arrowhead is meeting minus V0. So minus V0. Okay. So plus. It is in the same direction of diode and even this is in the same direction. Plus ID into 4.7K equal to 0. We need V0. I'll push this V0 to the right hand side. V0 is equal to ID into 4.7K. What is the value of ID? We have calculated here. Substituted. V0 will be equal to 6.51 volts. It is equal to 6.51 volts. This is how you find the value of V0 and also ID. Okay, so in the next problem, they're asking us to find the two voltage levels V01 and V02. This is very simple, but you can see here you have germanium and silicon diodes. This is germanium diode and this is silicon diode. So, for silicon diode, the threshold voltage is 0.7 volts and for germanium diode, the threshold voltage is 0.3 volts. This you have to make note, okay? So, this is very important point. So, this you have to remember it. Now, rewriting the circuit. Otherwise, I need to find only V0 first. So, let me take only this part of the circuit, only this part. Now, how does the circuit look like? This is V0 1. So plus V0 1 and this is ground. Fine. Now here you have a silicon diode and a 12 volts plus 12, right? So plus minus source. This is 12 volts and this is silicon diode. Silicon diode has a threshold voltage of 0.7. Now let me take a loop and calculate it. Here I'll be getting as minus 12 volts plus 0.7 volts, and if you just go like this, it is positive is head is meeting with the positive. So plus VO1 equal to 0. V01 is equal to 12 minus 0.7, which is 11.3 volts. Simple, right? So this is the first step to find the value of V02. So to find V02, it is enough that I take only this part. Okay. So now V02 plus minus is equal to the germanium across the germanium diode. Now this germanium diode, again I'll take the Kirchhoff's voltage law. Germanium diode has a threshold voltage of 0.3. So look at this, the arrowhead is meeting positive of germanium. So plus 0.3. It is meeting minus of VO2. Minus VO2 is equal to 0. VO2 is equal to, so let me push towards the right hand side. It becomes 0.3 volts. So that's all. So you got the values of V1 and V2 according to the question. Okay, coming to the last problem. Here you have to determine V naught in the circuit. You have to determine V naught in the circuit. You have two diodes here. One is silicon diode, the other one is germanium diode. So I told you that silicon diode has a threshold voltage of 0.7. So germanium diode has a threshold voltage of 0.3 volts. It means that germanium diode will turn on first. It will turn on first. How does the circuit becomes now? The circuit here will be like this. It will germanium diode will turn on, like it will turn on and make the circuit, and silicon diode will not be allowed to turn on, because once the germanium diode is turned on, it behaves as a short circuit path. It behaves as a short circuit path. If there is a short circuit path, the current will not take any other deviation. It will directly flow through this path. So here you will be having plus 12 volts, and what is the voltage drop here? It is 0.3 volts, and you need to find V naught, right? So applying KCL, V naught will be equal to 12 minus 0.3, which is equal to 11.7 volts. Okay, so this is how you find the value of V naught. Clear with this?
Thank you everyone. Thank you for watching this video. So if you have any doubts, you can write me back to my email ID. Like the video, share the video with your friends, and don't forget to subscribe to my channel. Thank you.